Hello everyone. Today I will solve the question 1680, concatenation of consecutive binary numbers, and the question statement is they will give us an integer n and we need to find the binary number of each digits from 1 to that number n, and we need to concatenate all that binary numbers, and we need to return the decimal of the final concatenated binary number. So like this, here in this example 3, they will give us 3, and we need to find the binary number of 1, that is 1, binary number of 2, that is 1 0, and the binary number of 3, that is 1 1, and we need to concatenate these words, this digits. So it will be 1 1 0 1 1, right? And we need to return the decimal value of this binary number. It will be 1 2 4 8 16, it will be 27, so we need to return this 27. So how we can solve this question? First I want to tell you, for this example only, like this, f3, like here you can see, for finding the f3, what we can do, we can do one thing. For f2 will be 110, right? 110. For 1 it is, for 2 this is, for f2 it will be 1 1 110 f2. f3 will be 11011. It is 3, right? So basically what we did, f2 plus f3, f2 plus f3, right? What we did, in f2 we just left shifted 2 digits, like 110. After left shifting 2 digits, it will be 11000, right? And if we add 3, that is 1 1, it will be 11011, our value, right? So what we can do, f2 left shift 2. What is this 2? The digits of the total digits in the binary number of 3, because we need to add 3 in the last, because 2 is 1 2 1 1 0. Now we need to add 1 1 for 3, right? After that we will get our final answer. So we will concatenate these two words, right? So we will left shift, how many times we will left shift? Number of digits in that final n. So we need to find this, right, for finding the final answer. So how we can find this? You can see 1 2 3 4, it is 1, right? It is 1 0, it is 1 1, and it is 1 0 0, right? So what is happening here, in every 2 to the power n digits, 2 to the power n number, like 4 or 8, you will see that the last digit will be 1 and all other digits will be 0, right? Like 8, it will be 1 0 0, all these digits will be 0 and this will be 1, and in 2 to the power n minus 1, all these digits will be 1, like 7, it will be 1 1 1. Digits will be lesser than this one, 1. If it is n, it will be n minus 1. Like here, if it is n, 3 will be n minus 1, 2 times 2 digits, and all these will be 1. So if you add these two values, AND operator, bitwise AND operator, 2 to the power n and 2 to the power n minus 1, you will get 0, right? You will get 0. Why? Because all these there is only one 1 here, 1 1 1. So you can find that whenever you will get 2 to the power n, the total numbers of digit in that number will increase. Like here it is 1, here it is 2, 2, but in 2 to the power n, that is 4. Number of digits is increasing 2 to 3, right? Here 1, 2, 2. Here number of digits is 3. Here number of digits is 4 because it is 2 to the power n. So we need to find number of digits for doing left shift. So now we can find the number of digits. Here in this example, f of 0 will be 0. For finding the f of 1, we will do f of 0 left shift 1 because we need to add 1 in the last, and we will add 1 in the last, and length of 1 is 1, that's why we have left shifted 1 time. Now the we will left shift 2 times because length of 2 is 2. F of 1, that is, it is 1, left shifted 2 times, it will be 1 0 0, and we will add 2, that is 1 0 1 0, it will be 1 1 0. Now we will left shift 2 times, it will be 1 1 0 0, and we will add 3, it will be 1 1 0 1 1. We will get the final answer. So now I will show you the code. Here answer is 0, that is the starting position. Mod for the modulus module, and length is 0 in the start. Now we are finding from f of 1 till f of n, and if I and I minus 1 and operator is equal to 0, we are increasing the length. As I told you, whenever we are getting to the 2 to the power n value, we are increasing the length, like 2 to the power n plus 2 to the power n minus is equal to 0. Here we are checking this, and we are doing answer left shift length plus that value by mod. So we are returning the answer. Now we are running the code. It's running. Thank you.